Good morning, my dear students. In this particular video presentation, we'll discuss some more problems meant for JEE. Actually, before going into the details of the first problem meant for today, we will discuss some basic rules behind binomial theorem, binomial expansion. Okay, we just see the expansion of a plus b whole power n in general is given by nc naught a power n plus nc1 a power n minus 1 b plus nc2 a power n minus 2 b square plus etc plus ncn b power n. I repeat, a plus b whole power n, the expansion in general is given by nc naught a power n plus nc1 a power n minus 1 b plus nc2 a power n minus 2 b square plus etc ncn b power n. And we have the following observations. Number of terms is equal to n plus 1. The power is n, there are n plus 1 terms. Okay, you can easily check 0 to n, there are n plus 1 terms. Here I have nc naught, here ncn. Okay, then coefficients are, let us say nc naught, nc1, nc2, etc., ncn respectively, from the first to the last term. Okay, then power of a gets increased one by one from, gets decreased one by one from n to 0. Here for the first term n minus 1 etc. up to 0. Then power of b gets increased one by one from 0 to n. For the first term power of b is 0, 1, 2, 3 and so on up to n. Okay, then sum of powers of a and b in each term is always n plus 0, n minus 1 plus 1, n minus 2 plus 2, 0 plus n, it is always n. And of course, general term. You might have seen general term in APGP, arithmetic progression, geometric progression, etc. General term here is given by TR plus an R plus 1th term. NCR, A power n minus R, B power R. You can just check. For the first term, R is 0, NC 0, A power n minus 0, B power 0 is correct. For the third term, you can check R equal to 2, NC2, A power n minus 2, B square. For this, the general term. I'll just repeat the whole process. The expansion of a plus b whole power n in general is given by nc naught a power n plus nc1 a power n minus 1 into b plus nc2 a power n minus 20 b square etc ncn in b power n. When the power is n, number of terms here is n plus 1. You can easily check nc naught, nc1, nc2, 0, 1, 2, 3 goes up to n. 0 to n, there are n plus 1 terms, n plus 1 elements. Now coefficients will be nc naught, nc1, nc2, ncn respectively. Then power of a gets decreased. I wrote by mistake decreased one by one from n to 0. For the first term it is n, for the second term it is n minus 1, for the last term it is 0. Power of b gets increased one by one from 0 to n. 0, here 1, 2 and up to n. Sum of powers of a and b in each of the terms, or each term is n plus 0, n minus 1 plus 1, n minus 2 plus 2, 0 plus n and so on. And general term here is given by TR plus 1 is equal to NCR into A power n minus 1 into B power R. You can check. For the first term R is 0, NC naught A power n, B power 0. For the nth term R is anyway n, NCn A power 0, B power n. For the third term R is 2, NC2 A power n minus 2, B square. Now for NCR A power n minus R, B power R is the general term. Similarly, if I write it as a minus b whole power n, practically speaking, I can write it as a plus minus b whole power n. Therefore, I'll replace every b by minus b here. Therefore, it will become nc naught a power n minus nc1 a power n minus 1 b plus nc2 a power n minus 2 b square plus etc. minus 1 raised to n into ncn into b power n. I repeat, okay, this is minus 1 raised to n, minus 1 raised to n. Listen carefully. It goes similar way. Number of terms will be, of course, n plus 1, and power of a gets reduced from n to 0 1 by 1, and power of b gets increased from 0 to n the same manner, and you have alternate signs, okay, plus minus etc. And if n is even, last term ends with an even coefficient, okay, I have alternate signs. If n is even, minus 1 raised to n becomes positive, last term ends up to be a positive quantity. If n is odd, it ends up with a negative quantity. And power of n, sum of powers is always n here also. Therefore here I'll have alternate signs. This much you are supposed to remember to apply your mind to do the problem which I'm going to tell you now, which I'm going to give you now. Let me just see here. Let me just check what happens, okay? Let me just check what happens. Let me just find out what happens, okay? Just see here. The problem goes like this. Find the number of terms in a plus b whole power 49 plus a minus b whole power 49 without actual expansion. Actual expansion, it means quickly. I need to find it quickly. Listen carefully. As per the rule which I already told you, there are 50 terms. Remember carefully. Okay. Here 50 terms, here I have 50 terms. Remember carefully. Okay. And of course, I have alternate signs. I have plus sign for the first one, minus sign second term, third term plus sign, etc. Okay. There are 25 terms having plus signs, 25 terms having negative signs. Now for while I add, actually the second, fourth, and of course the last term, 50th term will get cancelled, plus minus will get cancelled. Now for the remaining terms, the like terms can be added. For there are 25 terms automatic in the expansion. Okay, I repeat, there are 50 terms here. Again, there are 50 terms here. I have alternate signs here, okay, plus minus, etc. Okay, and of course first, third, fifth and 49th term will have positive sign. Okay, and the second, fourth, sixth and 50th terms will have negative signs. And while you add automatically, remember carefully, while you add automatically, all the second, fourth, 6th and 50th terms will get cancelled. There are 25 terms having positive signs, 25 terms having negative signs. Therefore, while you add the remaining like terms, I mean to say automatically, there are 25 terms in the expansion automatically. Similar way, if I take a plus b whole power 49 minus a minus b whole power 49, remember carefully, practically speaking here, while I subtract, I mean to say the first, third, fifth and 49th odd terms, 49th terms will get cancelled. The second, fourth, etc. 50th terms will become positive because of subtraction here. Therefore, I'll end up with 25 terms, adding the like terms. I'll end up with 25 terms in this expansion. Therefore, in general, if I have a plus b whole power 2n plus 1 plus a minus b whole power 2n plus 1, there are 2n plus 2 terms automatically. Plus 1 will give you 2n plus 2 terms. Okay. Therefore, out of which n plus 1 are having odd coefficients and n plus 1 terms will have even coefficients. Therefore, after cancelling out the plus and minus, I'll end up with n plus 1 terms totally in this expansion. I'm talking about the general possibility. Always 2n plus 1, n is a natural number, will give you an odd number. 2n will be an even number. 2n plus b plus 1 will be an odd number. Whenever the power is an odd number, number of terms will be an even number. Therefore, there will be 2n plus 2 by 2 terms which are positive, remaining or 10 plus 1 terms are positive, n plus 1 terms are negative. Therefore, while you add even or Even here a plus b whole power 2n plus 1 minus a plus b whole power 2n minus 1, a minus b whole power 2n minus 1, sorry. Okay, you add or subtract, I end up with automatically. There are n plus 1 terms in this expansion. Okay, 49 plus 1 by 2, 25 terms. If the power is, let us say, 79, 79 plus 1, 80, 80 by 2, 40 such terms are there. Okay, if it is 99, 99 plus 1, 100, 100 by 2, there are 50 terms in the expansion. A plus b power 99 minus a minus b power 99, or a plus b power 99 minus plus a minus b power 99. Therefore, in general, if a plus b power 2n plus 1 plus a minus b power 2n plus 1, or a plus b power 2n plus 1 minus a minus b power 2n plus 1, number of terms will be without expansion. I will be able to write quickly. There are n plus 1 terms in the expansion quickly using this particular using the expansion in general, which I explained at the beginning, the general expansion everything. Okay, therefore remember the basic rule behind the question, you'll be able to answer any such problem, okay, in a quicker way. Okay, thank you students for patient watching.